Okay, so this is the last section in 10.5. Hustle, please. Okay, here's what we're going to be doing. Here's our objective for the day. Here's our I can statement. I can use coordinates to find ratios of segments. Okay, so quick reminder of what we just did. I'm going to do it kind of in a streamlined fashion. This problem, like we mentioned, kids that take 7th grade math, they learn how to solve part-to-part ratios and proportions, part-to-whole ratios and proportions. This one is given as a part-to-part ratio, but you have to know the whole in order to solve it. So here's what we've got. We've got a part. One of those parts is Tim. We've got another part. That part is Carrie. And it gave us information about that. It said they're in a ratio of 6:7. The whole, as you guys figured out, is the jackpot. We're going to need to put jackpot in air quotes there, right? The whole is 13. So the way we solved this, a method that you could do every single time would be something like this. Let's do Tim over the jackpot would equal 6 over 13, because we know that whole, the part over the whole, is going to be 6 over 13. So this is going to be Tim over the jackpot of 143 is 6 over 13. Here comes that solving that proportion. We're going to multiply both sides by 143. Those are going to cancel. This is going to be an 11. And then we get Tim got this much. He got $66. Okay, now I think we got that on the last one, but how much does, well, what's one way to figure out what Carrie got? Subtraction, right? Okay, so one way to figure it out is do 143 minus the 66, which is going to tell us that Carrie gets 77? Yeah. $77. Okay, have we answered the question?
Yes.
We have. Let's go back and make sure, because they told us this. They told us that Tim to Carrie was a specific ratio. Let's take the actual dollar amounts. 66 for Tim, 77 for Carrie, and if you reduce that, you get 6:7. Does that match up with this right here?
Yes, sir, it does.
It does. Okay. So the key to this is figuring out what the whole is, and then we can match that up with the real life information. In this case, it was about the jackpot. Any questions there?
No.
Okay. So we've talked about this already, but just a reminder. Okay, when we're doing geometry concepts, formulas, shapes on a coordinate plane, we're doing what we call coordinate geometry. And in this section, what we're going to do, I'm going to add a word here. We're going to do some fairly simple geometry problems. And what we're going to do is we're going to solve these geometric problems. We're going to model them and we're going to verify them in 2 dimensions. And a couple of these are pretty easy. Some of them get pretty challenging. But if we get used to visualizing things and coming up with a method that works in 2 dimensions, then we can do things that are in higher dimensions that we have a really hard time visualizing, but we can rely on the method in order to solve it for us. So, really simple idea. This is what we're doing today. It says, for every line segment with endpoints A and B, there exists a point C between A and B, so between the endpoints, that will partition the segment into a given ratio. That's all we're doing today. So, in a nutshell, this is what we're going to do. We're going to take a line segment and we're going to chop it into 2 pieces. We're going to divide it into 2 pieces into some predetermined ratio, like that predetermined ratio for Tim and Carrie. And we're going to start off with a couple easy examples. First one is a horizontal line segment. We've talked about this before. Can somebody tell me something nice that they did for us here? You might look at below for a hint of what they didn't do for us below. Yeah, Zach.
They gave us more C.
Yeah, so they kind of did. They kind of have this arbitrary point, so they labeled it X, Y. They did something else nice on this. Si? They gave us coordinates. What's nice about this graph compared to the one down below? Crew?
It's got like a grid.
It's got a grid. Okay, so that's kind of nice. We're not going to rely on the grid as much. We want to make sure that our method works no matter what. So here's the deal. For this problem, it says find the coordinates of C so that the ratio of AC to CB is 4. Now, if that's a ratio, let's put that over 1. So let's come over and take a look at this right here. And notice that because this is a horizontal line, no matter where we slide C anywhere in between there, it stays on the horizontal line. It's the same distance above the x-axis. So the y-coordinate's going to be the same. So this is going to be a 2. All we need to do is figure out how far from A this needs to be in order to break it up in that ratio. So the first thing we're going to do is we're going to figure out how far is it from here to here. Now, I know you can count, but one way you can always make sure that you have a positive distance is you can always do the right end point minus the left end point. Right end point minus the left end point will always give you the correct number. So this is going to be 3 for that x-coordinate minus the minus 7. So how far is it from A to B? What is the entire length of AB? 10.
10.
Entire length is 10. So let's come down here and take a look. We already noticed that, hey, if you go from A to B, it's just going from A to C and then adding that little bit from C to B. So this is where we kind of transition from what we did in the warm-up to this. This is what they gave us from A to C to, and comparing that to C to B. That's 4 to 1. So what goes on the bottom here? Don't say anything out loud. So if A to C is 4 parts and C to B is 1 part, how many parts is it from A to B? Gavin, what is it? 5. It's 5 because we just add the 2 of those together. So what I've got right here is I've got the whole. Part 4, part 1, altogether we've got in the whole 5 parts. So this is going to be a 5. Any questions there? Okay. So we're going to take this right here, and this is a part to whole, which is AC to AB, and that's going to be 4 to 5. So this is AC. Remember, we don't know what AC is, but I've got this little proportion right here. I do know what AB is. Jack, how far is it from A to B?
It's 10.
It's 10. So just like we did solving the other one, I'm going to multiply by 10. Those are going to cancel. I'm going to get a 2. So from A to C better be 8. Now I told you we were going to start off with some easy ones, and you can almost visualize how this works out. So this is from A to C. So we're going to go that many units from this point right here in this direction. We're only changing the horizontal coordinate. We're going from the left point, so we're going to take this point right here, A, and we're going to add what we found. A to C is 8 units. So we're going to add those 8 units, and we end up at 1, 2, right? So there's the answer to the problem.
Why? What's the point there?
We shouldn't be bugged by the fact that it's over here. Remember, in geometry, do we go by the way things look, or do we go by the information? We go by the information, okay? Now, let's kind of verify this. We just figured out that this distance right here from A to C is 8, right? So what's this little bit right here?
2.
Tough question, 2. Nice answers on this one right here. So let's do the same thing we did before. In the original problem, they said that AC over CB was a specific ratio. AC on this one is 8. We have the actual length of it. It's like knowing exactly how much they got from the jackpot. CB is 2. And does that work out to be 4 over 1?
Yes.
It does. So it checks out. Do we have the right answer?
Yes.
Yes, we do. Okay, we're going to slide down and take a look at this one. Another one. Vertical line segment. Same type of setup. We don't have a grid here. We can do this. If we add the parts together, we've got 7 parts altogether. 2 of them for AC, 5 of them for CB, 7 parts for the whole thing. So let's do this. Okay, just like you can make an answer positive by doing right minus left, you can make this positive, and I realize you can kind of just look at it visually. Top minus bottom will always give you a positive answer. It doesn't matter whether the numbers are positive or negative. So if I do 19 minus 2, because that's the y coordinate, I end up with 21. Samara, are we doing okay? All right. So all we're going to do is we're just going to change the y coordinate. It's going to have the same x coordinate, so this is going to be a 3, and we're going to figure out how far up we're going to go. So that's going to be a 3 comma something. So I'm going to do the part to the whole. So I'm going to do AC to AB. AC is 2 parts. Andy, how many parts in the whole? How many? Say that again? 7, there we go. Now we can take this and say AC over AB, and we know that length of AB, 21, 2 over 7. Remember I said we were going to start off with some pretty easy ones? Times by 21. Those are going to cancel. AC is 6, right? So where is C? Three comma. We're going to take that -2, and we figured out, hey, AC is 6, so we're going to go up 6 units. This is 6. So it's going to be -2 plus 6. I end up with C equals, I got 3 comma 4. Is that what you got? Hey, D.
What if you did 5 over 2? Would you get the same thing?
No, you wouldn't.
I mean 5 over 7.
Okay, great question. Great question. So first of all, AC corresponds to 2 up here. If you did 5, you'd have to have CB up here, and then we'd be going from the top down to the bottom. But you could do that. It would give you the same answer. So his question just said, what if we figured this one out first? What is this one if you know this one's 6?
15.
How'd you get 15?
21 subtract 6.
21 subtract 6 is 15. Okay, so we got the answer. I want to do one more verification. Let's just double check this. AC over CB. We know what the answer should be. We know what the reduced ratio should be. AC is 6. Sai, what's CB? It is 15. And if I reduce both of those by a factor of 3, this is a 2 over a 5. Does it check out? Did we get the right answer? Any questions? Okay, flip the page over. Okay, you can kind of summarize this technique that we were using right here with a couple of quick lines. So if we're changing things horizontally, so if we've got a horizontal line, we've got a left end point and a right end point, okay, and A is that left end point, then C, all we're going to do is we're going to add a fraction of that entire length. So it's going to be that part to whole ratio, that scale factor, that's going to be that's how much of the entire length that we're going to add. The y stays the same. Same thing would be true if it's vertical. Then we're just going up and down. If we're going up and down, we're just changing the y coordinate. So this is going to be the part to whole ratio that we want times the entire length. Couple quick cautions. Every time we've done this, A is left or below B. So it's always looked like this. A is here, B is here, or A is here, B is here. There's nothing special about the letters we used, A, B, and C. You could use any letters you want. And like Wilson pointed out, if we did it differently, we could just start at the top and go down. So we wouldn't add that much, we'd end up subtracting that much. Make sense? Okay. Any questions? Okay. Let's take a look at these guys. Said we were going to start off with some easy ones. These are still horizontal and vertical, but let's take a look. So we've got these points. A is at -12, 5, and B is at 3, 5. So let's draw a picture of that. So So let's see, A is over here at negative 12 comma 5. B is over here at 3 comma 5. Can somebody tell me one of the coordinates of C? Smart, what do you got? The y would be 5. Yep. So I'm going to come over here and I'm just going to say C equals something comma 5. If you think of it in one sense, we got half the answer already. So we need the entire length from here to here. Right end point minus left end point, how far is it? 15. Because that would be 3 minus 12. That's going to give us a positive distance like we want. And then we're going to do that part to whole thing. Megan, how many parts in the whole here? 10. Very good. So we're going to do part to whole. And we're going to do AC to AB. Okay, we switch that bottom one. It's not CB anymore. It's not the part to the part. It's part to the whole, and the whole has 10 parts in it. So that's going to be 1 to 10. Nice fraction. AC, we still don't know what that is, but D and J, what's AB? How long is it from A to B? What is it? 15. You see why?
Yeah.
Okay. One tiny step to solve. Lydia, what do we do to solve that? Multiply by? Yeah, we got to get rid of that 15 right there. So I get AC equals, let's see, I'm going to cancel those off. So this is going to be a 2. That's going to be a 3. So from A to C is 3/2. Ugly. Let me dot that. So that means from here to here is 3/2. We moved it that much 3/2. Would you write the x coordinate as a fraction?
That's a fraction.
Fraction. Why do I got to do that to you?
The word problem.
Good point, but I asked you. I gave you instructions.
Lame.
Wouldn't it be negative 12 plus 3/2? Starting right here, we're going that far, right? So negative 24/2 plus 3/2? Negative 21/2. We okay with that? Okay. Any questions? We could verify that, but considering the time, I won't. Okay. If you figure out how far it is from C to B and make it into that ratio right there, it'll turn out to be 1/9. So let's come down and take a look at this one. This one's this one's a vertical line. So let's see. A is at 4, -2. And B is at 4, 6. Angela, can you tell us the entire distance from A to B? It is 8. 6 minus 2 will give us 8. Crew, can you tell us how many parts? Parts in the whole. So that's the part that are A, the parts that are AC, and the parts that are CB. So how many parts altogether?
13? What?
Close.
Wait, hold up. Oh, yeah, 12.
12. There we go. So we're going to do the part that we want, which is AC, over the whole, which is AB. And that should be in a ratio of, we take that top part, 5.
Over 12.
Take the bottom part, which should be the whole part, that's going to be 12. And now we have something that we can solve because we've got a link here. So we have AC over, Sai, how long is it from A to B?
8.
8. Whoops, 5/12. Multiplied by 8. And are you quiet because you're working?
Yeah. No.
10/3?
Yeah.
Okay, so that's how far we go up. We go up 10/3. So D came in late. Let's see if you can answer this. D, can you give us one of the coordinates for C? X coordinates 4. Okay. Caleb, can you tell us how we find the Y coordinate for C? Want to phone a friend?
Yes.
Who we got?
Crew.
Crew.
-2 plus 10/3.
There we go. We're going to start at -2, which is right here, and we're going to go up 10/3. So this is -2 plus 10/3, and we're going to make ourselves work on the fractions here. So this would be -6/3 plus 10/3. So altogether we get 4/3. Is that right?
Correct.
So 4 comma 4/3. That's where it ends up. Again, if you want to figure out the length of C to B, so this other distance right here, and then set up the original ratio, it'll work out. Any questions? Okay. We'll see. In fairness, remember yesterday I gave you a problem that 7th graders learn in 7th grade math, but you guys skipped 7th grade math.
Yeah.
If we showed this to 7th graders, their heads would explode.
Oh.
Okay? So, take a look at this.
Wait.
We've got AC, so from here to here is 2 parts. From here to here is 3 parts. That's CB. So the whole, crew, I'm coming back to you. How many parts in the whole? 5, thank you very much. Okay? Here's the awesome part about this. We only need to figure out the horizontal distance and the vertical distance. We don't have to go diagonally. Going diagonally is a huge pain.
Yes, I agree.
So here's what we're going to do. I'm going to drop a line straight down here and then come over here, and we're going to do a point D. And we're going to break this into 2 of the problems that we just did. So here's the deal. I'm going to go this far to get to a point, and I'm going to call that one C prime. And then I'm going to go up this far, and I'm going to call this point C double prime.
Huh?
And this point is 4 comma -1. So would you take a look at that, and would you make sure that this is the right point? Did I label that the right way?
Wait, how do we know that? Are we just guessing because of the grid?
Guessing what?
Because remember, like that last problem we did, it was like in the halfway. but
Okay,
it
are
was
you asking
a
about
small
these
number.
guys?
No,
Or are
the
you asking
D.
about the D? The D is because it's horizontal and vertical.
Look.
If I just go straight over here, that many points, follow that straight down, it's going to have the same X coordinate, right?
Okay, yeah.
Same X coordinate as this one, same Y coordinate as that one. Good question.
Yeah.
Anything else?
No.
Okay,
What is he doing?
how far is it from here to here?
It's 8.
7 minus -1 would give us 8. How far is it from here to here? 6.
6.
Okay, you ready? This is going to go pretty quick.
Oh, jeez.
So we're going to do the part to the whole. We want this part. This part is 2 out of all 5 of them. So AC to AB, oops, take that back. Let me change this.
Oh, jeez.
This should be 2 to 5. I'm doing this horizontally. So that would be AD. Would be this distance right here. I'm breaking this down horizontally. Just doing this one.
Is it AC?
Should be AC prime.
Oh, it should be C prime. Thank you for catching that. Thanks. Got it? Nice job. Okay, so this means we've got AC prime over AD, but we know AD now, don't we? What's AD?
It's 6.
It's 6. And this should be 2/5 times both sides by 6, and I get 12/5.
That's ugly.
I'm just moving it that much horizontally. So if you come down here, remember, we started today, we're going from left to right, bottom to top.
Oh, we added.
We start at -2, and we're going to go this much, 12/5. So in fifths, that's -10/5. So correct me if I'm wrong, this is 2/5. You okay with that?
I agree.
Okay. The math always makes sense if we do it real slow. I'm going to do this next one. See if you can set this one up a step ahead of me. We're doing the vertical one. So we're going to do the part
B to C.
to the whole. D2, who's got it?
B to C double.
C double prime. What goes on the bottom?
D to B.
D to B. And that ratio should still be this fraction of the whole thing. So it should still be 5 halves. So now I can do D to C double prime over, I know what DB is. That's like knowing what the jackpot is. So that's 8. This is 2/5. Multiply both sides by 8. And I end up with 16/5. So D to C double prime is 16/5. Love those fractions, right? So we're going to add 16/5 here. Let's see, that's minus 5/5.
So 11.
11/5.
That one actually looks real though on the point.
What's that?
That one looks real on the graph, unlike the first one.
You're right, it's in the ballpark, yeah. Okay.
Looks more like 3/5.
Can we have just like
Okay, listen up.
okay, Dad.
Circle the self-assessment. And can I see a fist of 5? Fist, I have no freaking clue. 5's, oh, I got this figured out. This makes sense.
It's like a how do you like a
Okay, all right, not too bad. Okay, a couple days ago we talked about this. So listen up, last thing, and then I'll hand out the assignment. There are times where we can take things and break them into a horizontal and a vertical. That's way easier than working with things on a slant. There was a topic that came up last year. We mentioned it a couple days ago. We do it for slope. You're right about that. That's a good one. I didn't think about that one. What else? Think it's something that starts with V. Did it last year. Mentioned it a couple days ago.
Vertice.
Nope.
Vertical.
Vectors. There we go. Okay.
Who said vector?
Now, Mason. Mason is always studying stuff and figuring things out. I'm thinking of something else where you break things into a horizontal and a vertical rather than sticking everything all together. So I'm thinking about motion. I think you mentioned it earlier this year. Thinking of something that starts with a P. Rhymes with aerometrics.
Oh, parametric.
Parametrics. Now, raise your hand if you know what parametrics are.
I thought you were talking
Mason does, because that's the way he is, and a couple other people. You will see stuff like that in a few years, so here's what I want you to get from this. First of all, would you cross off multiples of 4?
Yeah.
Good
I don't think I heard that loud enough. What was that? Right. Would you put a star by number 5? Put a star by number 10. You're going to need to think about, the top of this page at the notes where I said we're always going from left to right, bottom to top. You're going to need to think about those. Okay? Let's see. I had something else, but I lost it. Okay. Any questions? Yeah. I do have that back there. You're not going to be here?
We should do multiple.
I actually might want one too.
You need one also?
I'm
Okay.
gonna need one also.
Is it
Same.
solo ensembles?
ensemble. Yeah.
Who's not going to be here tomorrow?
Well, I have a different reason.
You have a different reason? Are you going to share that with everybody?
Yeah.
Okay. Okay, see me before you leave.
Don's at 8:30.
Okay, hold on 1 second.
Yeah.
See me, if you know you're not going to be here tomorrow, see me before you leave, I'll give you the practice test.
Actually, I might be. I don't know.
We've got Friday off. Have this done, we'll correct it first thing tomorrow. We'll take a few questions before we correct. Practice test tomorrow, test on Thursday. No school on Friday because it's the District Health and Wellness Day. So that means no homework on Thursday night and no homework over long weekend.
Let's go.
Okay, any questions?
What is your favorite fruit?
Favorite fruit?
Yeah.
Toss up between pomegranate and orange. Yeah,
What?
yeah. Oranges are good. Okay, nothing else?
Dragon fruit.
Okay, you got about 20 seconds. Go ahead and get your stuff together.
Mr. Laws, you dropped my card.